Morning students, as we have started with our topic derivative, and we have already discussed the definition of derivative from the first principle. So here I am just rewriting: if there is any function, real valued function, then the derivative at x point, that means f dash x, it will be given by limit h approaches to 0, f of x plus h minus f of x whole divided by h. So this is the simple formula to calculate the derivative of the given function from the first principle. And let us do few sums based upon this formula. So we will go to exercise 13.2, and here we will start with sum number 4, where we have to calculate or find the derivative of the functions from first principle, right? So the very first part of this sum is, let us see what is the function given. So here the function given is x cube minus 27. X cube minus 27, right? So let us calculate the derivative. So f dash x, it will be limit h approaches to 0, f of x plus h minus f of x whole divided by h. So now f of x, we know it is x cube minus 27. Here we will use, means here we will substitute the value of f of x plus h. So here it is just like calculating the value of the function at a point. So f of x plus h will be, here also I am going to write, if f of x is x cube minus 27, so f of x plus h will be x plus h whole cube minus 27, right? So here also we will write down, it will become x plus h whole cube minus 27. This is the value of f of x plus h, minus f of x will come as such, x cube minus 27 whole divided by h is there. So now we will just open the brackets and we will see the common terms, whatever are coming, they will get cancelled, and after that we will apply the limit. So a plus b whole cube formula we will apply, x cube plus h cube plus 3x square h plus 3x h square minus 27. Here the bracket, when I open, it will become minus 27 and plus 27 whole divided by h, right? So here again we are writing this limit h approaches to 0 as such, because till now we have not applied the limit. So plus x cube minus 27 plus 27 cancelled, we are left with h cube plus 3x square h plus 3x h square whole divided by h. Now from the numerator we will take h common and cancel, and it will become limit h approaches to 0. Here we have h square plus 3x square plus 3xh, and here when we apply the limit, it will become 0 square plus 3x square plus 3x into 0. First term and the third term will become 0, so the answer is 3x square, right? So we have done the same way as in the previous exercise. We have learned how to apply the limit, right? So the only difference is here in this formula, when we are calculating f dash x, we are calculating f of x plus h, then f of x, putting these two values, doing the calculation part, multiplication means applying the identity if it is there, adding, subtracting, then if any common term is there, that we are cancelling. Common h from the numerator we are taking and cutting it with the denominator one, and then application of limit. Okay, so this was the first part. Now second part is x minus 1, x minus 2. So that also you people will do the same way. So second part, when we start with, here our function is x minus 1, x minus 2. So better if we just simplify it, it will become x square minus x minus 2x minus 3x plus 2. So this is our function, corresponding to which, we need f of x plus h. So f of x plus h will become x plus h whole square minus 3 times x plus h plus 2. So when you calculate f dash x, it will be f of x plus h minus f of x whole divided by h, and that h will approach to 0. Okay, same way this sum you people will do. So I'm leaving second part for you people. We will go to the third part, right? So third part we have here 1 upon x square function. So once again, as we have to calculate the derivative, so we will write down from the first principle. From the first principle, f dash x will be equals to limit h approaches to 0, f of x plus h minus f of x whole divided by h. So if f of x is 1 upon x square, so f of x plus h will become 1 upon x plus h whole square minus f of x 1 upon x square will come as such whole divided by h. Now in the numerator part we will take LCM, okay, and these two terms product will come denominator. So how it will become? It will become limit h approaches to 0. Here I will get x square minus x plus h whole square divided by x plus h square into x square into h, right? I hope this step is clear to everyone. In the numerator we have taken LCM, so it will become x square minus this term whole divided by product of these terms with h also. So it will become limit h approaches to 0, and here x square minus x square minus h square minus 2xh x plus h whole square identity we have applied. Minus sign is there, so every term will become negative, divided by, here I am keeping it as such, x plus h square, x square and h. X square and x square cancelled, so we are getting limit h approaches to 0. Minus sign if I keep it outside, one h also I can bring outside. It is h minus 2xh. H is out, so here no h will come, divided by h, x plus h square into x square. H and h will get cancelled. Now we will apply the limit also. It is minus sign outside, 0 minus 2x divided by x plus 0 square into x square. So what is left here? We are left with, it is 2x. So sorry, here because minus sign is taken common, plus sign will come, plus sign will come. So minus 2x outside, and here we have x square into x square. 1x will get cancelled of the numerator with 1x from the denominator, and it will become minus 2 upon x cube. That is our answer. Okay, so we have done the same thing here also. The function is 1 upon x square. So f of x plus h, wherever x is there, it will become x plus h as such, whole square will come. F of x plus h minus f of x, we have applied, put the sub values, divided by h, and that h is approaching to 0. After that we have just taken LCM, and then opening the bracket, applying the identity, cancelling the common terms, and then application of limit finally, right? So this was the third part. Similarly, fourth part of this sum is homework for you people. The same way you will do. Okay, x plus 1 upon x minus 1. So if f of x is x plus 1 upon x minus 1, f of x plus h will become x plus h plus 1 divided by, in place of x, x plus h will come, minus 1. It will go like this. Okay, so here we will discuss one more sum that is based upon first principle, and It is sum number 10 of exercise 13.2 that we have to find the derivative of cos x from first principle, and all the remaining sums are now not based upon first principle, that we will do directly with the application of formulas. So let us complete this first principle topic first of all, and the function is cos x here. So we will go the same way, right? So we know from first principle how we write down. So we will write down from first principle f dash x, this is equals to limit h approaches to 0, f of x plus h minus f of x whole divided by h, right? So we will just apply the limit h approaches to 0, it will become cos. Now if you notice, f of x is cos x, so it means f of x plus h. So where x is there, here it will become x plus h. So the angle x has changed to x plus h. Same thing we will apply here. It will become cos of x plus h minus function that is cos x as such whole divided by h. Now here it is our choice which formula we want to apply. We can apply cos of a plus b formula also, or I can go for cos c minus cos d formula also, right? So if you apply cos of a plus b formula, that is cos a cos b minus sin a sin b, that is one way, or you can go the other way also. Cos of a means cos c minus cos d formula, that is minus 2 sin c plus d by 2 sin c minus d by 2. Any one method we can apply. So first I am going to do, if I apply cos of a plus b formula, it will be cos a cos b minus sin a sin b, and this cos x will come as such whole divided by h, right? Now if you want, we can separate the terms, means we can take the terms common and then separate. It will become limit h approaches to 0, okay? And here we have cos x, cos h and cos x. If I take cos x common, I am left with cos h minus 1 whole divided by h, and this term is coming as such minus sin x sin h whole divided by h, and here I am writing first term and third term we have clubbed here, and this second term we are writing as such. Now in the next step, what we will do, we can separate the limit. It will become limit h approaches to 0 cos h minus 1 upon h, and this cos x is coming as such minus limit h approaches to 0. Similarly, sin h upon h is coming into sin x will come as such. Now we know our formulas. What are the formulas we have here? I am just writing the results here, that limit x approaches to 0, 1 minus cos x upon x, this is 0, right? And the other formula is limit x approaches to 0, sin x upon x, this is 1. So here if you notice, in the first term cos h minus 1 upon h, it is exactly same 1 minus cos x upon x. X approaches to 0, h approaches to 0. So here the answer will become 0 into cos x minus limit h approaches to 0, sin h upon h, it will become 1 into this sin x will come as such, because the limit is for h only and a limit will be applied here. This sin x is coming as such. So we are left with 0 minus sin x, that is minus sin x. So it means the derivative of cos x function is minus sin x, and we have done it with the help of first principle. Now we can use it directly also. So here I am just giving you we can have few formulas straightforward also, as I have proved here that what is the derivative of cos x. Okay, similarly, if you go do this, what is the derivative of sin x, right? So here if I take the function sin x, and same way you apply the derivative from the first principle, limit h approaches to 0, it will become sine of x plus h minus sin x whole divided by h. When you complete it and calculate and apply the limit directly, you will find that the derivative of sine x, so f dash x, here we will get cos x. This is also a standard result. So this part I am leaving for you people. You must do it. Okay, and this is the sum of exercise, but this sum I am giving to you. If function is sin x, prove that the derivative is cos x. You can do it with the help of first principle, and we after this we have direct formulas, right? And these direct formulas we will learn in the next class. So I want you people first of all to practice the sums based upon first principle, and then we are going to the main formulas, right? So thank you students.